Hello out there. I hope you're doing well on this beautiful day. What is our focus today? Today what we'd like to focus on is a regression. Okay. What does regression entails? Do you know? Do you have any idea what it entails? Okay. But before we do that, I'd like us to start with a question. And I'd like you to think about this while you're at home there. Let's see what we have. So my question is, have you ever thought about this? How do we predict the future based on data collected over a period of time? How do we really predict the future based on the data collected over time? Can we really predict? How much data do we need to predict? Can I have 5 data sets and predict what will happen? Okay? Another way we can predict that is using this regression analysis. Okay? So regression analysis, which is a model with independent and dependent variable, the x and y, okay? And we can use that to predict the future. You could have seen also with the COVID-19, okay, that data have been collected on a daily basis, how many people infected with the coronavirus. And data was used whether to have a lockdown or something, and data was used to predict whether we're going to have a second wave or third wave, something of that nature. Yes, using historical data, one can predict the future, okay? But to do that accurately, one will need a large data. I mean, using 5 data sets or 10 or 20 might not really be that efficient or optimal, but using a large data, you can accurately predict what will happen in the future. Okay, fantastic, great. So now what are we going to focus on? We'll look at the line of best fit. After the line of best fit, we'll look at linear regression from there, and we'll look at something called interpolation and extrapolation. Okay, that's when we're actually trying to predict using data. Okay, so let's look at some of the keywords: forecasting and statistical model. What is forecasting? Okay. Surely, if you weather, also the weatherman will focus the weather. Say, okay, there's this chance that it might rain tomorrow. That's another way of forecasting, predicting whether it will rain tomorrow or it will be hot or cold or something of that nature. That's actually forecasting. If we have data and we want to predict the future using the data we collected, we're also forecasting. Are we all together? Then, what are we using to forecast? We're using a statistical model to forecast that. And a linear regression is one of the statistical model that can be used to forecast. Forecast meaning to predict what is happening in the future. Are we all together? So if we have collected the coronavirus data, we want to see whether, and we predict, yes, we're going to have more infection by next week. We're actually forecasting using the data collected. That's what we're doing, okay? But to forecast, there are different models. When we talk about a model, it's model to focus the data. But we'll focus on one model today, looking at linear regression on how can we forecast. Okay. So without wasting time, what is independent variable and dependent variable? Okay. So on a Cartesian plane, my x is independent variable and y is the dependent variable. I mean, independent variable does not depend on other variables, but dependent variable, it will depend on the x variable, it will depend on something else. Are we all together? Independent and dependent variable. Then from there, let's look at the line of best fit. Okay, you've probably heard of the line of best fit. What is the line of best fit? So when a relationship exists between, very important, between 2 variables. So the 2 variables we're talking about here is the independent and dependent. Could be x and y, okay? So when relationship exists between two variables, a line of best fit can be drawn on a scatter plot or scatter graph. What is a scatter graph, guys? If I have x and y as coordinates, I put a point on the Cartesian plane in the first quadrant, I put all those points. We call that a scatter graph or scatter plot. Are we together? Okay. So the simplest relationship is a linear relationship. So we're going to look at linear relationship only when you draw a scatter plot. Okay, fantastic. So the line of best fit, we draw our points on a scatter plot and we find a line which actually all those lines closer to that, all our points get closer to that line. Okay, but we'll explain that in more detail. So a line of best fit. For a linear relationship, the line of best fit always passes through the point x bar, y bar. What is x bar, y bar? So those are the mean, is the average. Okay, so remember that x bar is given by sigma x over n, and y bar also is given by sigma y over n. What does that mean? This implies what we're doing is the sum is the average of x, and this is the average of y. Remember that the average of x, we take all independent variable, all the x's, we add all of them, we divide it by how many of them. Okay? We do the same on the y-axis. We add all the y values, divide by how many y values do we have. Are we together? Then that's the average for y. So what we're saying is that the line of best fit must pass through the mean. So you have to create a new point on the Cartesian plane by calculating the average using x, the average using y, create a new point, and the line of best fit must pass through that mean, the point, which is the new point you must create. Fantastic. Are we together? Makes sense? Okay. Let's see what does that look like. So here we have points. So we say the line of best fit can be added to the scatter graph, okay? Showing the mean, January temperature, and altitude. So here we have temperature and we have altitude. So the points were drawn. Those are the points there. Are we together? For us. So to draw the line of best fit, we create the new mean. Are we together? Which is that point. How do we get that point? So that point is x bar, y bar. The x bar, this point is by the average by, say, 10 plus 20 plus 30 plus 40 plus 60 divided by 1, 2, 3, 4, 5. Are we together? And you do the same thing on the y-axis. You add all the temperature and divide it by how many data set. Then that will give us that point. Then we draw our line of best fit. Are we together? Are we together? So it might not be exactly the same line of best fit, but what must be the same, it must pass through the same mean. The same mean is that point. The average for x and the average for y. The line must pass through that. Very, very important. Are we all together? Okay. Fantastic. Great. Now, I would like us to look at a linear regression. What is a linear regression? What is this linear regression? Okay. So, a linear regression is actually the line that represents the line of best fit. It's actually the best one. Are we all together? It will be the equation of the line of best fit. That will be the linear regression. Okay, in a simplest term. So linear regression involves finding the equation of the line of best fit on the scatter plot. It's find the equation of the line of best fit on the scatter plot. That's what we're doing. That's our linear regression. Okay, let's see. So the equation obtained then can be used to make an estimate of one variable given the other variable, of the other variables, okay? So there are two cases to consider, depending upon whether we wish to find the value of y given the value of x, or we want to estimate x given y. Okay. We deal firstly with a situation where both variable x and y are random. Okay, I'll illustrate that. And where we wish to predict the value of y given x. Are we all together? So if I find, we said that linear regression is the equation of the line of best fit. In this context, we're talking about the equation of a straight line. And if we have that straight line, we can find y using x. If we have x, we can find y. Okay. So let's look at this. I'll show you. So the best fitting line is the one that minimizes the sum of square deviation. Okay. So this is the line of best fit, if you can look at that. But remember now, I have all those points. Those are the points there. Those are the points there. Those are the points there. Those are the points. Those are the points there. So we want to choose the equation of a straight line that minimizes the deviation from the line of best fit. Can you see? We want to reduce that distance. Okay. Okay, are we together? So those are the sum of the deviation from the points of the scatter plot. Are we all together? So if that sum, the deviation from the line of best fit is so large, we don't have a good model. We don't have the good or the best line of best fit. Are we together? So we want to minimize this. This is what it's actually trying to say. Are we together? So sigma, this just means the sum of those deviations, all of them, all of them, all of them. We want that to be minimum as possible. Are we all together? Okay, that's the line of best fit. So this does not mean that the regression is only linear. It could be a different model. It could be parabolic, it could be exponential, it could be any function we can think about. Okay, so the idea is to minimize this. So now this is our line of best fit. So the distance, di, are sometimes referred as residuals. You know, worry about that. So those deviations. So it implies that those d1, d2, d3, d4, d5, those are the residual. So di is the vertical distance between the ith point and the line. That's what we're trying to do. Are we all together? Great. So, regression. The best fitting line should pass through the mean, which is the average, which is x bar, y bar. Okay? The equation of the least square regression, okay, of y is given by this. Y, actually there must be a copy there. Y equals to a plus b times x. This looks more like the equation of the straight line. Are we all together? So you know that the equation of a straight line, you're probably used to y equals to mx plus c, which is similar, where m is the gradient and c is the, so this is the slope, and this is the y cut, or y intercept. Okay, so it's the same. So even here, so this is the slope of the regression line, and this is the estimate. So both the estimate for y cut and estimate for the slope of a line. Are we all together? And we spoke about it must pass through the mean which is average for x and average for y. Okay, guys, so we're going to take a short break now. After the short break, We'll still look at how do we actually find this equation of the least square regression. How do we find that? Using our calculator and actually using the equation of a line. Okay, I hope you're doing well out there, and remember to keep working hard, keep the consistency going there. Okay, you don't do your mathematics because you're writing a test. It's a continuous thing that you do on daily basis, and you become continuous on that. Okay, great, fantastic. Hope to see you shortly.